This is the first video about the various properties. So in this chapter, we'll be talking about the various properties like electronic configuration, atomic ionic radii, ionization enthalpy, hydration enthalpy, melting and boiling points, density, electropositivity, oxidation state, flame color, as well as photoelectric effect. But before we start, I'm someone who believes in it's easier to learn it as a comparison instead of just studying, okay, let's do alkali metals and then let's start talking about alkaline metals. Not only do you basically complete, you know, one topic for each of these at one go, it's just easier if you do it this way. That's what I believe. So the first one is the general electronic configuration. As I said, it's going to be NS1 for alkali metals, whereas in alkaline earth metals, it's going to be noble gas and NS2. Now, N actually in both cases is going to represent the valence shell. The what happens is the electrons in the s orbital are not very tightly held, and so this makes alkali metals as well as alkaline earth metals electropositive. And out of these two, alkali metals are the most electropositive elements in the respective periods. Now, because of that, alkali metals also can form the M plus ions, whereas these form M plus 2 ions. And the due to the high reactivity and the ability for them to lose this one electron to become like to acquire the noble gas configuration, in nature we never find them alone. So basically, they have to make sure that they don't undergo chemical reaction. Usually, things like sodium is very reactive. So even with one droplet of water, it bursts up. And so that's stored in kerosene. So these are the electronic configuration of the elements of the respective groups. And each of these cases, you have 2s1, 3s1, 4s1, 5, and 6s1, and 7s1. Here, on the other hand, you have 2s2, 3s2, 4s2, 5s2, 6s2, and 7s2. Next is the atomic and ionic radii. Again, I'm pretty sure you learned about all of this. Across the period, you have the decrease in the atomic radius because as we go from the left to right, there is an increase in the effective nuclear charge, and that in turn leads to the shrinking of the atomic radius. Now, when we talk about the alkali metals, these have the largest radius compared to their respective in their respective period. And this largest atomic and ionic radii is due to the fact that going across the period, you have the increase in the effective nuclear charge. So there will be a decrease in the atomic radius. And in case of alkaline earth metals, they're relatively going to be smaller. And that's the same reason why they have a smaller size. It's because of the effective nuclear charge. And as we go down the group, if you notice, there is an increase in the atomic radius in both these groups. It's not just for alkali metals or alkaline, but it's for both of them. And that is because as we go down the group, there is an addition of another shell. And because of that, the nuclear charge is not able to hold it as tight as it would. And because of that, you have an increase in the atomic radius. The next one important thing over here, the monovalent for alkali metals, the monovalent cation is going to be smaller than the ion because cation has formed because with a positive. I mean, first of all, cation has a positive charge, and the cation itself, because it has one electron less than the element, the effective nuclear charge is more, and because of that, the size is less. And we've learned about all of this in the third chapter. So that's about atomic and ionic radii. The next one is ionization enthalpy. Ionization enthalpy, first of all, if you remember, ionization enthalpy is the ability. So for an element to have a low ionization enthalpy, it is easy for that element to lose that electron, to lose an outermost electron, or rather to lose an electron from its outermost shell. So alkali metals have the lowest ionization enthalpies in their respective periods, and this is because of their size. Bigger is the size, farther is the electron from the nucleus, easier it is for them to lose an electron. Not only that, when an alkaline when an alkali metal loses an electron, it gets the configuration of the noble gas, and noble gas configuration is quite stable. And because of that, it has a tendency, its ionization enthalpy is quite low. And when we go down the group, if you notice, there is a further decrease in ionization enthalpy because the atomic radius decreases as we go down the group. And this is something you learned in the third chapter. That's the same thing here. Here we're discussing it with numbers. Not only that, it's noticed that the alkali metals have a higher second ionization enthalpy. And that is because the cations which are formed, as I told you, have this configuration that's going to be N-1 P6, right? In case of, except for lithium, the remaining, this one is going to be 2p6, 3p6, 4p6. So this configuration is very stable, and the atom does not want to lose that one electron to become, to have a +2 charge. So that's the reason the second ionization enthalpy for an alkali metal is extremely high. Now, when we talk about alkaline earth metals, they are going to have a slightly higher ionization enthalpy than the ones in the corresponding alkali metal group. For example, if you notice, for lithium, it's 520, beryllium, it's 899, sodium 496, and magnesium is 737. So there is a huge difference in terms of the ionization enthalpy. And this is again to do with the atomic radius. So the atomic radius of alkaline earth metals is slightly smaller than that of the corresponding alkali metal. And because of that, when we compare across the respective, or rather the corresponding alkali and alkaline earth metals, then we notice that the ionization enthalpy for these elements is relatively higher than this one. Secondly, as we go down the group, obviously the same thing is going to get followed. As we go down the group, there is a decrease in the ionization enthalpy because of the increase in the atomic radius. Now, when we talk about the ionization enthalpy, as I told you over here, it is difficult for the alkali metals to lose this configuration and come to this one. Okay, but on the other hand, it was noticed that the alkaline earth metals had a tendency to lose this one electron, and their the second ionization enthalpy value of alkaline earth metals was actually was much smaller than that of the alkali metals. We're only talking comparison. So it was noticed that alkali metals and alkaline earth metals, when we talk about the first ionization enthalpy, alkali metals seem to be having a lower value and alkaline a higher value. We know that. Okay. But the second ionization enthalpy of value of alkaline earth metals is much lower than alkali metals. And this is big than the second ionization enthalpy of the alkali metals. And this is again because of the configuration. When an alkali metal loses an electron and leads to the formation of the noble gas configuration, and that in turn does not prefer losing, and so because of this the amount of energy required to remove this one electron will be high. On the other hand, over here there is some amount of energy that is required for the removal of one of the electrons, and that's when you get the configuration similar to our alkali metal group, and it is easier for it to lose this one electron and form the 2+ ion because it gets the electronic configuration of the noble gas. And that is why you have a difference, and this configuration is not particularly stable. On the other hand, this is very stable, so is this one. With that, we're done discussing about the three properties. One, we started with electronic configuration, then we talked about the atomic and ionic radii and the ionization enthalpy. Again, it would be better if you go back to the third chapter, recap as to what those properties are, and then you learning or understanding all of this much is going to be much easier. The next video we'll be continuing with the various properties of alkali and alkaline earth metals.